So welcome again, guys. My name is Nigel LeBlanc, and I am the CEO and founder of Cyber Warrior Network. Essentially, we've created the Call of Duty for ethical hackers. And while folks play the game, we validate their knowledge, skills, and abilities. And then we can match them up to any real world job opportunity or even any training or educational curriculum. And today I'm excited to be speaking with Graham Berry and also our dear friend Shamim. And we're going to continue the conversation on confidential computing. Now, some of the questions, just because of my background in esports and gaming, I will frame it this way, but that doesn't mean that that we have to limit the conversation to that. So I will turn it over to Graham, and then we'll follow up with Shamim for a brief introduction, and then we'll jump into the conversation. Graham?
Thanks, Nigel. Hi, folks. My name is Graham Berry. I'm a product leader in the Azure Confidential Computing team, and I'm in the deep infrastructure layer to revolutionize how data can be protected while running in a cloud environment of Azure.
And I am Shamim Naqvi. I'm the CEO of a startup company called SafeLiShare. And the SafeLiShare platform uses Microsoft Azure as a first implementation, and very happy to be using the confidential computing facilities being made available by Microsoft Azure.
So, Graham, last week or the last time Shamim and I, we discussed, confidential computing and how that could essentially protect against exposing sensitive data. Again, not just in the spectrum of esports. From your experience, how could someone use confidential computing to prevent breaches like, take, for example, exposing any type of PII or any type of pertinent or sensitive data within any application? Yeah,
the foundation of confidential computing is protecting data while it's processing or while it's in use. And the capabilities that exist here are right down to the hardware. So it's encrypting the memory where applications and data is processed. So confidential computing is able to bring a defense in depth that is much beyond all of the engineering and operational procedures that exist today. Like, let's take Azure, for example. We have a very secure cloud. It's around operational monitoring protections to make sure outside hackers can't get in. And now it's come to a point that says, okay, how do we go deeper and protect against more intelligent threats? Like if admin access is gained, so there's a privileged admin that is able to go and infiltrate the system and be malicious. Confidential computing is there to add more defense in depth right down to where that data is processing in the memory. So regardless of the industry or scenario, it's around protecting right to the core of where applications and data are processing. So just foundationally, if you've covered before, the solutions that already exist, protecting at rest and in transit, and now completing that data lifecycle, confidential computing can even protect that data while processing. So even admins, even the software that runs, say, in a cloud environment, like a hypervisor, these are all blocked from being able to gain any access to that data, even while it's unlocked for processing.
So I recently, Cyber Warrior Network, we recently graduated from Generator Accelerator. And one of the startups in the cohort, along with ours, is a company called Hertzian, right? And this is where I really learned about the encryption down to the actual chip, right? And Shamim, we talked about how the part of confidential computing, it's not just the actual software layer, but it goes down to the hardware, right? So my question for both of you guys is that, why do you think that this is not something that is more widely known? And what can we do to increase or even, spark these conversations about these capabilities?
Well, I would love to hear what Graham has to say, but from my point of view, when I first started as a research scientist at Bell Labs, one of the lessons I learned was that it takes about 7, 8, 9 years for a new technology to find to become well known and find its way into the marketplace. Confidential computing in its modern form is about 7-8 years old, and it is starting to see an upswing now. So while it may have started out in a slow fashion, I think it is picking up. As to why not just software only, there's an old adage that says that security should be grounded in the laws of physics. And I think that if you build hardware according to the laws of physics, then you have a very solid base for ensuring trust in the hardware itself. So there is a more impregnable situation results when the basis of the trust is the root of trust in the hardware.
I would echo very similar. And from a cloud perspective, Azure being a cloud provider here, it's also where customers and solution providers can go and defer trust between different vendors and providers, right? So from an Azure perspective, we source our hardware from third-party vendors in Intel, AMD, NVIDIA. So the root of trust going to the hardware means that it's actually outside of Azure as the cloud provider. So we can remove Azure and Azure operators from the trust boundary when it's rooted down to this third-party hardware. Yeah. And I'd also echo the same in terms of you're spot on. Confidential computing in today's form of hardware manifested 7 or 8 years ago. And I echo the time it takes, because let's look at the web. When encryption in transit on the web transitioned from HTTP to HTTPS. This was like early 2000. It was invented in the late 90s. Early 2000s, you might see credit card sites getting switched over to HTTPS so that you can say, hey, this credit card transaction is secure. And then now all sites, it's the de facto standard, 20 years later, everything is just expected to be HTTPS. It's even built into the browsers like Chrome and Edge. This is the de facto expectation that it's now flagged if it's not HTTPS. I see the same happening in the compute space with confidential computing. The fact that it's new hardware also limits us in terms of how fast we can get confidential computing more pervasive, right? I frequently tell customers, like, if I could switch the light switch and then instantly all of the servers in Azure had this confidential compute capability, it would be fantastic. But the reality is we have to cycle through and deploy new hardware in order to bring these new innovative capabilities from our hardware vendors. And then over time, we'll get through pervasiveness in cloud infrastructure. It'll be available on the edge as well. And then ultimately through the services running on top of that infrastructure as well.
Yeah, that's really interesting.
I'm sorry, if I could add just a bit to what Graham said. It's very interesting that he says that one way to think of this is that the cloud provider is being taken out of the trust equation. You trust the hardware, or the hardware provides a guarantee. And so you have one less thing to trust in your portfolio. The service provider, if you are a service provider and you are running a platform, then confidential computing also allows the service provider to be taken out of the trust equation. So I, as a service provider, as a platform operator, I do not get to see the data that is being submitted and used and computed. And I don't get to see the application if it's a contributed application as well. So not only does the cloud provider come out of the equation, but the service provider or the platform operator is being taken out of that equation. The hardware self-attests as to its integrity. And so you have less parties to trust in your equation.
Absolutely. Yep.
So, Shamim, you bring up a really interesting point, which kind of triggered a thought here. Even devices like our iPhones, right? So utilizes confidential computing. And that new update where it says, do you want to share, privacy, allow to track or not? I mean, what are the implications for companies that are essentially tracking your data would confidential computing give us, the end user, the ability to decide, have more autonomy or more power to decide of what data that they can and can't get access to?
Yeah, I mean, all these privacy regulations are ways of allowing the consumers and the subscribers to have more control over their data. If you are a service provider and you are receiving your customers' data, be it a consumer or be it an organization as the customer, then it behooves you to have the endpoint produce encrypted data and do the key management in such a way that the control of that data lies with the data who happens to be the data provider. This means that the data provider has to now explicitly grant permission to the platform to be able to decrypt the data. Right? So it comes under the control of the data owner to maintain the keys of this encryption and allow the platform to get the keys only if the data owner allows the keys to be given to the platform.
Gotcha.
Yeah, and I think Shamim brings up a great point there, that it's around putting the control into the hands of the data owner. And from that point of view, it's maybe a story about trust and verify. So it's like you're still using a platform, you're still using a platform provider, and you're verifying the exposure of your data. You're verifying the environment or how your data is going to get used before you go and give it permission. So I'll speak from a cloud perspective. More of our customers are asking to verify the environment where their data is getting processed in order to meet some of these data privacy regulations, to know that it's being processed in a secure way, know that it's being processed without exposure to any outsiders, and then being able to say, yep, I trust the stack, both hardware and software, to say this is allowed to go and leverage my data. And when you brought up the iPhone case, I thought it was interesting because we do see a heavy trend in the retail industry happening right now. This is where advertising is getting locked down because of data privacy regulation. And we're getting looked to in the, we as the global confidential computing is getting looked to in being able to provide a platform to enable privacy preserving data combining in order to do things like better advertising and better use of people's personal data in a more secure way. So I think there's a few of these industries that are really going to take hold of responsibility with protecting people's data, protecting the privacy of data, so that it can't just go rampant through partner companies or any of these scenarios like exposing your personal data for the purposes of advertising. Confidential computing will help ring that in to say, now I know how my data is being used, and I only give consent for it to be used in certain ways when I know it's being held and processed responsibly with things like confidential computing.
Yeah, absolutely. I mean, right off the top of my head, we have, that would be perfect for healthcare. And lots of federal military applications. Another big one, I think, when we talk about the end user and normal everyday person, we are now living in the age of IoT, smart devices. So when you look at tell us how you think confidential computing can protect personal data or any type of digital assets across multiple devices. So because we're talking about the fact that there are different manufacturers, right? We've already established the fact that the hardware is very important, right? And Graham, you brought up a really interesting point. Let's say there may be an upgrade for one particular set of hardware, which is inherently connected to a different piece of hardware that the upgrade is not available. So how do you factor, using this confidential computing, across multiple devices?
Yeah, I'll take a crack at that first, and then I'd love to pass off and hear from Shamim as well. The importance here is doing an industry movement and not just one hardware vendor or one cloud provider or certain scenarios. Microsoft did co-found a consortium to do this in the Linux Foundation to have open conversation around how to standardize confidential computing for the future. This is the Confidential Computing Consortium. And this includes all the hardware vendors, multiple hardware vendors, cloud providers, and of course, solution providers as well, so that we can all together establish both the terminology, the standards, and how things can implement. And this includes both cloud and edge, so that it's not constrained to certain scenarios, right? And then from that point of view, I'll bring up a couple interesting scenarios, because you mentioned healthcare and how data can be protected from multiple angles. There are lots of places where there might be healthcare data that's locked on premises, right? So then the challenge that would come up is, hey, we're not going to move this data to the cloud, but in the age of AI coming to fruition, how can we bring some of these intelligent models to that data? And that's some of the scenarios that we get into that are these cloud plus edge data, or cloud plus edge type scenarios that say, hey, I want to bring my model to that data on-prem or on the edge, and then be able to process it there in a secure and privacy protected way. And in this case, it's not just the data. This is actually also protecting the model. So think about this in terms of more generally, like people's biometrics, even in healthcare, genomics data. There's lots of sets of data that are very personalized. These can't be de-identified as easily, right? So in those cases, to bring the data locally to where these, to bring the model locally where these data exist, whether it's on a phone, an edge device, an IoT hospital device, enabling confidential computing capabilities pervasive will enrich the ability to protect IP of researchers, IP of solution providers that want to have their algorithms and AI run locally on these devices, as well as keeping the privacy preservation of patient data and health records and that more complex data like genomic data and biometrics. And that's the future, when everything gets more to scale and pervasive. Again, with all the hardware providers being part of the movement, and then with the just time it'll take to get more standards and pervasiveness, it's just a matter of time that more and more will pop up until it's just de facto compute again. We won't have to say the word confidential; it'll just be compute.
Yeah. It's just to add a little bit. I was speaking with a healthcare researcher who is interested in rare diseases, and in that field, the data sets that this particular researcher works with are small to begin with. And he was complaining about the fact that you really cannot afford to de-identify the data sets, because you start out with a small enough data, and by the time you get it anonymized, there's not much left to work with. So it's sort of interesting. And the game in several verticals, sort of including in the field of digital advertising, in the field of healthcare, etc., the game is combining of data sets to create longitudinal records. And so therefore, you Graham, a few minutes ago, talked about the advent of confidential computing-based clean rooms, where different parties can contribute data that can be combined based on the policies that the data was shared with. And in those cases, protecting the model that's going to process the combined data is also very crucial. So there are sort of interesting ways that de-identification is not always the first step. that needs to be done. Perhaps we should look at solutions in which the de-identification happens to the results of the computation, not before you start to compute the results.
I 100% agree. That's a fantastic point.
The other point I want to make is that one shouldn't think of secure enclaves or confidential computing providing secure enclaves that are a single entity. When we talk about secure enclaves, what we mean is that there are a series of these secure enclaves that are securely connected with in a graph-like fashion. So you can actually start something. You can think of a series of secure enclaves forming a data pipeline that starts at the cloud and comes all the way to the edge. So it doesn't matter whether the computation starts in the cloud and comes to the edge, or it starts at the edge and comes into the cloud. It's a single federated data pipeline consisting of a series of stages, and each stage is a confidential computing node.
Yeah.
So a couple of really interesting thoughts here. One of my past experiences, I worked with DARPA, and essentially we're setting up some hackathons, right? And part of the big issue with military and federal agencies is declassifying of information. And you guys just talked about, de-identifying and where should that happen, right? Real world scenario, we have an app like TikTok, right? So there is all sorts of not just PII, but metadata that's involved in the tracking, right? And I don't think people really understand how pervasive and how much data TikTok is tracking. And there's been, tons of coverage. Actually, over the last, I think, 3 months, the governor has banned, the governor here in Texas has banned TikTok from any of the state networks, right? My question to you guys is, who has the responsibility to protect using confidential computing, right? To protect any sort of data that the end user does not know that the application is tracking, or does know and has no power to deny access to that data. I know this is much more of a policy versus technology question, but I'm interested in you guys' thoughts.
Yeah, I'm trying to tease that apart. I think there's a couple aspects here. So when we talk about pure responsibility, it's hard to just point to one entity. So we can think about what the different parties involved can do as their part, right? So from a cloud provider perspective, making making confidential computing more pervasive so that if a service is running on a cloud, so here you gave an example of an application like TikTok, if that's running on a cloud provider, one layer of the stack is that cloud provider doing their due diligence to bring confidential computing as the backbone for where these applications are running. Ultimately, the solution provider, the app developer, or whoever's deploying and operating the service, has their responsibility on top of that cloud layer as well, because this is a case where the solution itself has the ability to have themselves in the loop or explicitly design the solution so they're out of the loop. And I like that you brought an example of like a messaging app or a social media type app, because there's a good example that it does exist in the marketplace today that runs on confidential computing, and that's Signal Messenger. So this is an organization that said, we want to keep security and data privacy as our top priority. So they designed a system to obfuscate themselves out of the trust boundary. And that's the point that Shamim made before, that says that solution provider can also design themselves out with the use of confidential computing. So if the question comes to them and says, who are your users? What user data do you have? The answer is,
I don't know.
We don't have it.
Yeah.
But we should be careful. There is a distinction to be made. If you're running a computer program on a confidential computing node, and the computer program is performing a general computation, then what we know mathematically is that because of the computational complexity based arguments, it is impossible to predict ahead of time what that computer program is going to do. It may engage in malicious behavior. So in some sense, the responsibility writing computer programs is still with the developer. If somebody writes a malicious TikTok, I'm not saying that TikTok is malicious, but if somebody wants to write a malicious version of TikTok, they can write it. And it would run on a confidential computing node. It would just mean that the policies that are being followed by that computer program happen to be malicious. It would be doing some form of I/O or doing system call that it really should not be doing.
Yep.
So we have a notion of a curated application. It's no different than certain service providers that say we have an app store and we will vet the app first before we allow the app to run. So in some sense, confidential computing may, in certain cases, start to work with curated apps that on top of the confidential computing layer that Graham was talking about, also has a layer of app store policies that the app must follow.
I think that's a great point to bring up. And when I think about that, it always comes back to transparency and auditability, right? So that's part of that added responsibility that says, hey, if we want to truly show that the solution is doing what you think it should be doing, there's that notion that says, well, how transparent is that development? How transparent can the consumer of that software audit? Or in the case that Shamim gave, is it being audited or checked by someone that it's not doing something that is unexpected of what the user expects and keeping their data protected? And I got to tell you, that's what a lot of customers would come to us as Azure, as a cloud provider, because we don't just provide the infrastructure. We do have services and utilities that we provide to make end-to-end solutions work. And many of the key ones many of those key pieces we're looking to have produced out in the open, have them as open source so that they can be audited and the build of that software can be reproduced and validated. So that's becoming that it's the verification of the environment and the transparency or auditability of what's running.
Yeah, that's a crucial point. Yeah. I mean, exactly. The confidential computing may not be sufficient all by itself to stop malicious acts of computer programs, but it does provide tools that allow you to say which computer program did the bad thing.
Yeah.
So I think this is a perfect segue into our final question in this segment here. So in the very near future, we may see an emergence of quantum computing as a threat to traditional data security measures, right? I would love your views on how we can use confidential computing to adapt to those new technologies and continue to protect our sensitive data.
Well, again, this is one of the reasons why you should base your security and trust mechanisms on the laws of physics. If they're based on the laws of physics, then quantum mechanics in principle is a central law of physics, and therefore your security protocols should still be okay in principle. The fear that certain parts of the quantum computing fraternity have looked at and sort of expressed is that it may be possible for certain types of encryption to be broken. So you see, when we say that we take some data and we actually use some encryption technology to protect the data, it means that it would take a certain amount of computational effort to break that encryption. Mm-hmm. If you have quantum computation, quantum computers, and they work fast enough, then the amount of computational power available to you may be so large that you may be able to break down certain types of encryption schemes faster than what the theory tells us today. So typically you would hear statements like, if I use 256-bit or 512 AES GCM encryption algorithm, it'll take of the order of a gazillion years to break the encryption on a modern day machine. But if I have a quantum computer and it turns out to be possible to do it with a 16-hour run or something like that, that's the sort of risk that people talk about. However, there are counters. First of all, NIST is looking at quantum encryption based algorithms. There is also the possibility that even classical encryption may be fine if the key lengths are adequate. So this is not something that's going to happen right away. I think that in the next decade or so is the sort of time frame that people who are working in this space are talking about.
Yeah, I 100% agree. And if we break out into those layers that we talked about before, right? Like we said, there's the hardware layer that's actually doing the memory encryption and protection. And then there's the data layer around the keys that protect your data. So those concepts that Shamim talked about there, it's about, hey, this is what Azure would do. We're working with our hardware vendors to say the encryption that's done down in the hardware at the memory layer, let's work to make sure that the future iterations of that are quantum safe. And equally within Azure, the mechanisms that have to bring customers' keys in and out, that do the data decryption and keeping things protected in rest, in storage. Let's make sure those keys are all quantum safe as well. So when we think about protecting data from quantum attacks of the future, it's across the different mechanisms of encrypting data today, and then reinforcing those with the same improvements over time that Shamim was talking about in terms of increasing key length or adapting and doing new encryption mechanisms.
Gotcha. Well, guys, this was a really interesting conversation. I myself have learned a lot. I want to thank you for taking the time to sit down and have this conversation with me. And till next time.
Thank you so much, Nigel.
All right.
Thank you, friend.